It's an interesting looking question. The data is the following. Suppose f of 0 equals negative 3. And also we suppose that f prime of x is less than or equal to 5. And the question is, how large can f of 2 possibly be? It's an interesting question because on the face of it, hey, we don't have enough data. I don't know what's f of x. How in the world can I tell how large can f of 2 be? Right? But one thing we can realize that we have x equals 0 and we have x equals 2 and we have f prime. So we can assume that the function is continuous and differentiable on the interval 0 and 2. Okay, so we assume it's more than an assumption. We actually we know because if the derivative exists, f of 0 exists, and we are told that f of 2 possibly exists, then we pretty much know that the function exists on 0, 2, and as well as the derivative exists on 0, 2. So we assume that f of x is continuous on 0, 2, and differentiable on the open interval. Okay. So we apply the mean value theorem. So how we apply it, we're going to say that f prime of c is supposed to equal to f of 2 minus f of 0 divided by 2 minus 0. And here we're going to use one of the alternative forms that we wrote at the bottom of the mean value theorem. I'm referring to these two, which is essentially, if we solve for f of b minus f of a, we get these two. So let's do it. We can write from here that f of 2 minus f of 0 equals f prime of c times 2 is 2 minus 0. So, and this is, and the next step is f of 2 equals 2 times f prime of c plus f of 0. And now we just replace with what we know. Well, we know that f of c has to be less than 5 or equal 5, right? So let's write f prime of c has to be less than or equal to 5, and f of 0 equals negative 3. This is given to us, so f of 2 has to be less than or equal to 2 times 5 minus 3, or we end up having 10 minus 3 is 7. So this is the maximum value. So we can say that f of 2, not f prime, f of 2 the largest value is 7. The largest possible value of f of 2 is 7, and this is the answer to the question. And I believe that you have something like this in tonight's homework.